This conference will now be recorded.
Well, hello everyone, and welcome to this, the first seminar of the Ideal for OMOP training course. It's fantastic that we're getting started with this now, and things are really getting underway. Some of you may remember that we're basing this course off a course we ran a couple of years ago, very similar. And if we've got a journey ahead that's anything like what happened with Ideal for RWE, then I think we're all in for a really good time. Excitement, learning, friendships, networks, differences of opinion, challenges, but ultimately the chance to come together to produce some really high quality research in cancer. So I'm really excited. I hope you are too. If we can move on to the next slide, please. Let me tell you what we're going to be doing today. And let's start, in fact, with some introductions. So I'm James Anderson. You may remember me from the introductory call we had last month. I lead on a lot of the work that we do in DIGICORE, and for the I3 project that we're working on, I lead on a lot of the training work for that. Also really pleased to have a couple of other people with us today. James Brash, another James. Again, if you were on the introductory seminar last month, you'll recognize him. He's our guru and expert on OMOP. And then Will as well, hopefully another familiar name. If it's not, it will be soon. Will is an integral part of supporting the training that we run as part of the program. So what I'd like you to do just over the next couple of minutes while we go through the agenda is please do say hello in the chat, and we'd love to hear who you are, where you're based, what your role is. And because this is going to be a program where we get to understand different people and different cultures, and we collaborate internationally, we British love talking about the weather. So if you'd like to share what the temperature is outside where you are, that would be a nice thing for us to know as well. And I bet very few places are as cool as the 13 degrees it currently is in the UK. So please do that. Please say hello in the chat. That would be fantastic. Could I also ask people to go on mute if possible, please, just to keep it clear so we can hear what's going on. And already great, already getting some greetings through Poland yeah, there we go. Golly, 5 degrees in France, so much colder. Okay, very good. Maybe it's not so cold here. So I'll let that kind of come through in the chat. Do have a look there, because these are people you're going to be getting to know increasingly well over the coming days, weeks, and months. So let's talk about what the purpose of today is and what we're going to cover off while you're all busy introducing yourselves. So if we could go to the next slide, please. Well, we started the first one. We're introducing ourselves and introducing the program participants to each other. I'll also present a little bit of analysis of the different groups that we've got and the different people who've come together on this course. I'm going to give you a bit of a reminder on the purpose and the structure of the program. You should be starting to get familiar with this, but I think it's probably helpful just to give you a refresher on the big picture of how things are going to evolve through the summer and then through into the latter part of this year and into 2025. So the nature of the training changes and we start to work increasingly in teams. The main attraction today will be learning more about some of the principles and techniques of OMOP, and that's where James Brash is going to come in. Looking forward to hearing what he's got to say about that. And then finally, we'll wrap up with just a recap of what the next steps are. But we also want to let you know some of the resources that are going to be available to you as part of the program. In particular, we're building a SharePoint website that we are hoping will be able to be a really useful resource for you all and a kind of repository for information, and also a means of collaboration. So those are what we're going through over the next hour. If you've got any questions as we go through, feel free to speak up, or it might be easier for you to just pop those questions in the chat. We'll keep an eye on that. We want to make sure that we're going to be as clear as possible, and everything is all the questions that you have are answered. So with that in mind, next slide, I think, yep, let's go on to a little bit more about who's joining us today. So you all very kindly provided us with some information about yourselves when you signed up. And I just wanted to pull out a couple of points that have come through. So firstly, there's over 70 people have registered for the course. That's a fantastic result for us. It means there's a lot of interest. It means we've got over 40 centres, 40 organisations represented, and actually also a broad range of countries, from Ireland to Norway to Georgia to Portugal, from right across Europe. And as I think you probably realise by now, a key part of this programme is going to be international collaboration, bringing together researchers from across Europe, from different countries, to collaborate together. So we've got a fantastic geographic mix, which gets us off to a good start. If we then go around to the bottom left, you also indicated your skills and expertise. So we've got a good balance there. We've got a good proportion of clinicians, but we've also got supporting functions such as biostats, coding, all the skills I think we'll need to pull together and work together on actually conducting research. Critically, also, a good proportion of you all actually have access to data, whether it's primary or secondary care data. As we get into the study part of the programme, actually having access to data, being behind the firewall, is going to be important and actually a key part of all the teams. It doesn't mean necessarily that if you haven't got access to data, there won't be a role for you, but actually having access to data is going to be at the core of the study teams as we look to build them out. And then finally, top left, we've got a range of different cancer indications. And what's really nice about this is actually, if we think that when we collaborate, we will most likely be collaborating in study teams based around particular tumour types. We've got good reason to believe here that in urology, breast, colorectal, lung, gynae, heme, maybe even head and neck, we could look at the potential for studies that operate across three or more countries. So that's a really promising thing as well. Now, a number of you, when you filled out the registration, indicated that you were generalists, and that's great, and you're very welcome. Just start to think over the coming weeks about, is there a particular tumour area or tumour type that you might want to be particularly interested in supporting if you wanted to join a team? Because as I say, the teams generally form around particular therapeutic areas, particular tumour types. So if you are a generalist, do have a think about where you might want to contribute, where you might want to get involved. So in sum, a large, diverse group. We're well set for success, I think, on the programme. If we can go to the next slide, please. Okay, just quickly to recap the programme then. I won't go through the details of this, we covered it last time, but remember, this is a programme for early career researchers aimed at a range of functions, and we saw some of that coming through on the previous slide. We're talking about technical and leadership skills, both equally important, and of course, a key part of what we're doing is this idea of learning by doing and coming together in these teams, writing protocols and delivering proof of concept studies. There is funding available. That's an important point to note, that can provide in due course as the teams form clinical backfill. There may be other support as well that we're able to provide to you, but we want to make sure that the studies have the resources they need to succeed. So we have that funding. We have an independent leadership advisory board overseeing the disbursement of that funding. And I think I spotted in the chat Rachel Giles. Was very pleased to see Rachel here today. She's actually on our leadership advisory board, as is Dr. Sue Cheeseman. So we'll be looking forward to their input and expertise and guidance. When's it happening? Well, obviously it's starting now. Let's go to this slide then. That's fine. So we've had the recruitment phase. through till October now. We're going to be having the series of seminars, the basic training, and we build towards team formation, getting organized into teams, and you'll start working on developing your own study concepts. Then as we get into the autumn, those study concepts will be assessed and funding will be allocated, and we'll move into the second phase that will take us through into next year, which will be much more around the doing, the conduct of the study, but with support continuing through that. I guess one point to note is that, as I mentioned, the data is going to be an important component of this, and access to data. Because this is a program based around OMOP, we will need that data almost certainly conform to the OMOP standards. But the good news is two things. Firstly, over half of you reported that you already have that. And secondly, it will be some time before we will actually be conducting the research. I think it'll be probably well into Q1, maybe even Q2 next year when we actually start doing the research. So there is time. For example, if you're in the I3 program, that's aligned with the timescales for deployment in your centres. And if you're outside the I3 program, there's time for you to continue to build and refine your OMOP implementation. So that's the long-term view, building towards these teams, these studies, and the kind of conduct of the research using the OMOP standards. But let's rewind now. We are
I think we've lost you, James. Can you hear us?
Yeah,
yep,
I can hear you. That was really weird. It automatically muted me, which probably means even the technology thinks it's heard enough of me for the moment. I've got one more slide though, and then I'll pass over to James. So if we could just go on to the next one, please. So this first bit is over the next couple of months. It's very much seminar based, the learning, and we've got 6 seminars scheduled. So today we've got that first introduction to OMOP. We've then got, as we get into May, a couple of seminars looking at some of the specifics of study design, both from a kind of, I guess, epi perspective, but also from a technical perspective, as we think about how we might conduct database and OMOP studies, what the strengths and limitations are. I mentioned Rachel. We're really pleased that Rachel will be presenting one of the seminars later in May around how we can involve patients in real-world research and why that's important. Then there'll be one on the important topic of data privacy, and in particular, helping you understand how some of the approaches that we've developed allow data to remain on-site behind the firewall, but to be able to conduct really sophisticated federated analysis on OMOP research instances. So there'll be some good learning there, I'm sure. And then the final one will be a more of a focus on actually the practicalities of the team formation, how you apply for the funding. And they're really pleased to say that we're going to have some of the graduates of our previous program, Gaber and Ellen, will be coming back to talk about their experiences. So we've got a program ahead. 2 things to say about this, I think. Firstly, as it says at the top, it's a working draft. We've got some flexibility here. If there are particular topics that you would like to learn more about, do let us know. Contact me or Will, or you can send an email to the training address. We can see how we can accommodate that in the seminar program. So it's not totally set in stone. And I think the other thing to say is that, you know, this is a huge topic. We're actually covering a lot of different areas here, which in themselves could have many, many hours of training. The objective, I think, is not after each seminar that you suddenly become an amazing expert with in-depth knowledge in the field. What it's meant to do is introduce you to concepts, give you some resources that you can follow up on, and give you enough understanding so that you can actually write a sensible research protocol outline at the end of the process. There'll be continued support through phase 2 to help you actually, you know, make that research protocol deeper and clearer and conduct the research. But where we want to get you to is enough of an understanding, enough kind of knowledge, if you like, by June, July, that you're able to come up with a sensible protocol that we can that can be conducted on an OMOP database. And I think that goes for today as well. So James has got some great content for us. He's going to go through some of the principles, some of the elements of OMOP, and really to give you a sense of what it is, what's possible, why it works. And we're also going to give you some resources to go away and look at. So I think that's enough from me, and I'll hand over to James now to tell us more about OMOP.
Thank you, James, and thank you everyone for tuning in. So I'm going to give an introduction at a high level of OMOP and some of the key principles underlying OMOP. So this is the problem space. When we're talking about running these network studies across different hospital sites, we run into the problem that different hospital sites might have their data in different formats and using different vocabularies, clinical coding, which can be local, global, and so forth. And essentially, that's a major impediment to running a network study, because you have to understand how this data looks behind a firewall where you often can't actually see the data. You then have to design an analytical package that can accommodate each one of these data types. You then have to iteratively work on that package with each individual site. And you can see already this process is quite large, it's not scalable, it's quite expensive, and there's also a lack of transparency to it, because we're not dealing with one package, we're dealing with multiple analytical packages and different database types. So this is the reason why data standardization is so important. The idea that we can take our healthcare databases and put them in the same format, using the same clinical codes and vocabulary, we can overcome some of the impediments of the classical network study. We'd only have to design one analytical package, which in theory could then be run across all databases that are using the same data structure. The analytics can be designed remotely, because as a data scientist, I understand what the database should look like and which code should be used. So I don't actually have to see this sensitive patient level data that's behind the firewall of these different sites. And I would also argue that by having a common data model and only having one analytical package that runs across the multiple sites, say over 10, over 20 different sites, you do get an increased level of reliability and robustness there, because every individual analytical package you have to build and tailor to a different database type just increases your room for error there. And this is an illustration that you'll quite often see in the OMOP Odyssey community about the data standardization process. Essentially, if you imagine that the iron is our analytical package or our research study, the raw data comes in different socket formats, and you can't use that package across them. If we can standardize all of those sockets to the same output, then we can run this one analytical package across that network. And really, that's what OMOP is. OMOP is just all about the standardization of healthcare data. And there's 4 elements to this. The first is the standardized common data model, which we're going to go into detail today, as well as the standardized coding system. The idea that the same tables and fields should be used to store the healthcare data, with conventions about where the healthcare records should go, and also that the healthcare records are represented using the same clinical codes across all of these databases. If we have the same standardized common data model and we use the same standardized vocabularies, we can then build standardized tools from that. And that's not just analytical tools, which we will cover in one of the future lectures here, but we can also build standardized data quality tools, because we expect, again, the same data model structure, the same vocabularies. We can run these analytical packages, these quality packages, which will inform us if there's issues with our data to do with completeness, plausibility, and so forth, and can also be used to tell us how good our OMOP transformation of the source data was. And again, I did briefly allude to it, and we will cover this later in the session, so I won't stay in it too much, but from having a standardized common data model, there's a network of OMOP users who have developed a range of analytical programs that can run against that common data model to tackle very common research questions or support programs for the real-world evidence generation. So today we're really going to focus on those first two pillars, which are the OMOP common data model and the standardized vocabulary. So what you see on the screen now is an overview of the relational table structure of the OMOP common database. And we're going to go through these different elements in a second, but there's several principles about the OMOP database that you should be aware of. So first of all, it's a patient-centric database. So that means that in this person table up here, we will have an ID for each patient, and that will then link to all of their clinical records throughout the other tables of the OMOP database. So it's patient-centric, it's following the patient journey. Second is that it's all about standardized structure. The idea that there's these conventions on how the OMOP database should be set up, what fields should be included in the tables, which fields are essential, how they should link together, and so forth. That should be standardized between each site that has an OMOP common database. The third is that the OMOP common data model is domain oriented. So you can see on the right that we have these different colored squares around, and then within those we have different tables which are quite intuitively named for what's included in those tables, and we're going to go into that more detail. Essentially, OMOP is very heavy about having specific domains for specific elements of healthcare records. Number 4 is an important one, and this is a question that we often get as a team that uses OMOP for our analysis, is that OMOP is designed in a way that can be used across different data sources. So OMOP should be able to accommodate electronic health records, claims records, registries, oncology hospitals, and so forth. That's the aim of the OMOP common data model design. And the second part of that as well is that each of these tables in the OMOP common data model are designed in a way that the source data is also preserved. We won't have enough time to look into the details of that today, but I just want you to be aware of that OMOP retains the source data in its table. So even though you'll be working with a standardized code in your network analytics, if you ever needed to look back as to where that standardized code came from, it's recorded on each of these OMOP common data tables as well. And the final part here is more of a technical element, and that is that OMOP is database platform independent. So it doesn't matter if your database is on Snowflake or Redshift or Microsoft Azure, something like this. OMOP is database independent. It'll be able to work across these different systems. And actually, the community has developed various tools that allow you to run the same analysis across these different database platforms. So they're the principles of the OMOP common data model. We're just going to have a little dive now into actually what this data model looks like. So the first is the who being the persons. Where is the information about patients stored, and also about providers? So we have these two tables here, the person table at the top and the provider table on the right here. So the person table is going to give each patient a unique identifier. It's going to have information about their sex, their date of birth, and that patient identifier is then going to link to all the other tables of the OMOP common data model, so that you can then trace back to which patient each one of these records applies to. The other who is the provider. So if you have information about the healthcare provider, such as their location or their specialty, all that information is going to go into the provider table. That's the who of the OMOP common data model. The what is really about the clinical records. So the clinical records for each of these patients. And they really fall under this wider domain called the standardized clinical data domain. And then under that, we have these different tables as well. Oh, yeah, sorry. Am I still there? My computer just went blank. Can you still see me, James? Yeah, perfect. Under this domain here, this is where we're going to store our clinical records. So I'm quite familiar working with some of the people in this call in the prostate cancer space. So if I had a patient who came in for their first GP visit, that visit would be recorded in the visit occurrence table. The GP puts them onto a specialist, and the specialist actually diagnoses them with primary malignant prostate cancer after a series of tests. So that diagnosis is going to go into the condition occurrence table. Any of those tests are going to go into the measurement table, so our PSA tests, our staging, and so forth and so on. And then following that, my patient might go on to receive some ADT therapy or some chemotherapy. Any of those sort of treatment records, medication, drugs, chemotherapy, and so forth is going to go into the drug exposure table. And this patient might then go on to get some surgery, to a radical prostatectomy, for instance. Surgeries and any other type of procedure is going to be saved in the procedure occurrence table. And what you really start to understand with OMOP is that it's named very intuitively. I think a lot of you could have probably, if you were having a guess at where I said those records would go, you could probably have pinpointed the correct tables for each of those record types. So we covered the who. The what is the clinical records that goes into the standardized clinical data tables. The next is the where. So any information about where is captured in these standardized health system tables up here. So the location gives information on addresses, cities, counties, and zip codes. This essentially, for those of you who are slightly more technical, will work as a primary foreign key to each of the persons or providers and so forth. And then any information you have about a care site is going to be captured in the care site table as well. If you're just working in one hospital, I imagine that's probably not going to be diverse, but if you're working across a hospital network, that table might be a little bit more populated there. The next is a bit of a swerve. So the next is the how. So OMOP, it accommodates all of this data retention. So information about patients, information about the providers, their clinical records such as their diagnosis, drugs, medications, procedures, even their location, their care site location. But how we use this all for research really comes down to the standardized vocabularies, which we're going to go into a little bit more detail in a second. And some of the important tables here are the concept table. So this is a full list of what we call the OMOP concept IDs. If you're not familiar with the term concept ID, essentially think of it as OMOP's clinical codes. We have a table that tells us the relationships between these clinical concept IDs as well. And I'll elaborate on that a little bit more later. But in OMOP, a lot of these codes are actually linked together through different relationship types, which you can then leverage in your analytical design. OMOP makes use of vocabulary hierarchies, so you can look up those vocabulary hierarchies in the ancestor table, and again, I'll show you that in a bit more detail. And then finally, the OMOP common data model will have a cohort table shown over here on the right. And this is really the core of the analytics. So once we've identified a selection of patients that we require for our study, we're going to save information about those patients in the cohort table, such as their cohort definition ID. So for instance, metastatic prostate cancer patients will have an ID. Then there'll be an ID for all of the patients in that cohort. And then each of those patients will have what we call the cohort entry date, so the index date, and then also a cohort exit date, the time at which you no longer consider those patients to be part of the cohort of your study. So essentially what I want you to know there is that information is also captured within the OMOP common data model, and we utilize this table essentially for every single study that we're going to be running. So before I go into the standardized vocabulary, because I'm aware that I gave you an overview of the common data model in about 7 minutes, I want you to be aware that OMOP is it's public, it's open source, and all the information to set up an OMOP instance is publicly available. So if you want to know more information about the OMOP common data model and the tables and conventions that underpin the OMOP common data model, you can go to the Odyssey GitHub, where you can look up the CDM version. I'm looking at 5.4 here. And on the left, it has each of the tables that are in the OMOP common data model. I can click on one here, so condition occurrence. And it's going to give me a description of each one of those fields that's within that table, what should be populated in it, what data type, whether it's essential, primary, foreign key, etc. So usually if we give detailed training on this goes on for 4 hours. So I'm going to let you guys in your leisure read through the conventions of the OMOP common data model and what these specific tables do. But also on your OMOP journey, you're going to refer back to this frequently. I do still. I've been using OMOP for 3 years now. I'm always cross-referencing against these conventions, even at this point. So pillar 1 of OMOP standardization is the common data model. Pillar 2 is the standardized vocabulary. So in OMOP, again, we talk about concepts, and the idea of a concept is it's a representation of a clinical event. and it will have an ID, and that's essentially an OMOP clinical code. In OMOP, we talk about three types of concepts. We have the standard concept in the middle, and very high level, all you need to know is that the standard concept is the codes that you're actually going to use for your research. So when you're building your analytical packages out, and you're getting ready to share those across a research network, it's the standard concepts that you're going to actually look for in each of those tables I just showed you. The non-standard concepts are a sort of bridge to the standard concept, and essentially we don't use them in our analytics except for some edge use cases, but it allows us provenance to look back to see where that standard concept came from. So if you remember, I said at the beginning, one of the principles about OMOP is that it retains the source information within the tables as well. Non-standard concepts is a way that you can go back to find out which vocabulary a code came from. Classification concepts are really utilized for building out your code lists. So as you'll see in a moment, OMOP relies heavily on ontology hierarchies, and the classification concepts essentially allow you to use already established clinical hierarchies such as ATC or MEDRA and build code lists in OMOP using those other medical vocabularies. So let's go into this in a little bit more detail rather than just on the high level. So the idea of the standard concept. So again, the standard concept is the codes that you will be using for your research. They're the codes that populate and represent clinical events in the tables of the OMOP Common Data Model. And essentially the idea of them is this. So what you see on your screen on the left is a series of non-OMOP codes from other clinical vocabularies that represent atrial fibrillation. So in ICD-9, atrial fibrillation is 427.31. In SNOMED, it's 49436004, and so forth and so on. The idea is that once you OMOP this data, it doesn't matter if your data started in ICD-9, Biobank, or Nebraska Lexicon, and so forth. By the time it's reached OMOP and the standard concept ID, it will always be represented by this code 313217 and under the name atrial fibrillation. And this is a really key point. This is a key point about the interoperability and the standardization of OMOP, is that it doesn't matter what the source vocabulary is. In principle, once it's in OMOP, it should look the same in every OMOP database. So atrial fibrillation will always have this code, regardless if it's one of my internal databases, a partner's database, and so forth and so on. The non-standard concept ID, which I referred to on the prior slide, on the left, we don't use this in our research except for some edge cases, but now you can see where it comes from. So here what we have, before we get to the standard concept ID on the right, we go for an intermediate. So ICD-9 427.31 goes to this intermediate code here, and then it goes to this code on the right. And again, it's this non-standard intermediate that just allows us to trace back to the original source data. So if you imagine, for instance, in my condition occurrence table, if I looked up a record of atrial fibrillation, 313217, there's going to be a column in that table that will also have one of these codes, which allows me to know that this record originally came from ICD-9, ICD-10, and so forth and so on. This is useful for quality checks, just data provenance, and also there are some edge cases as well where I've used the non-standard. So if you look at this slide here, and I've got these codes on the left, and I talk about translating them through. So the Odyssey community, which is the OMOP user community, have now mapped a substantial number of vocabularies into OMOP. So this is just an overview, and it's definitely out of date, but it gives you an idea of these are all different clinical vocabularies which have now been translated into OMOP. So if you're working with one of these vocabularies, you can translate your codes into an OMOP equivalent. I'm just going to give you a quick demonstration of how this looks using one of the OMOP tools. So this is a tool called Athena. You can access this from your browser. It's publicly available, and the best way to think about Athena is two parts. One, it's a tool for translating codes into OMOP concept IDs. So if you've got an ICD-10 code or an ICD-03 code and you need to know the OMOP equivalent, you can go through Athena. And it's also used to look at the relationship between concept IDs. So if I show you that walkthrough of the mapping of a code, and I take, for instance, this code here, C34.1. I can search it on here. I know that this is I'm going to choose the vocabulary, so I know that this is an ICD-10 code. So I'm going to choose my ICD-10 here. Then what I see at the top, I've got this record, this code here, and this is malignant neoplasm of upper lung, bronchus, or lung. This is an ICD code for lung cancer. And if I continue to look here, I have a code here, an ID here. This is the concept ID, but it's non-standard. So again, as I said to you guys, this is the intermediate. So we start with the C34.1. We then go to this intermediate code of 1567488. But now I need the standard concept. If I want to do research using this code, I need the standard concept. So I can click on here, and there's this important table within OMOP called the concept relationship, which we're basically viewing on this browser here. And in the concept relationship, you'll have something called the non-standard to standard code. Okay. And really, this is the principle about how we do this mapping. Obviously, we don't, when we're doing a full database mapping, we don't one by one go through this website, but this should give you an overview, an idea of the principle. You start with a non-OMOP vocabulary, you map it into a OMOP, typically it goes to a non-standard code, and then you have to look up the relationship, which is non-standard to standard, and then this code here is a standard concept. It has the code 4151250, and I know that this code is always going to represent malignant neoplasm of the upper lung, bronchus, or lung in my OMOP database, regardless of what the starting source data was. There's obviously some nuances with that, but that's the general principle. So I kind of actually showed this slide here. So how do we go to a concept? How do we identify a standard concept ID? So I'm going to speak more from the analytical stage now rather than the actual original ETL. So there's two ways that I would typically go about this. We can either map over from a code, as I just did there. So if you're more familiar with working ICD codes, or you're more familiar with regional vocabulary or something, you can map those codes across to find the OMOP equivalent. But OMOP also handles pretty well text searches as well. So if I go back to Athena here, and I was interested in comorbidities at this time, and I wanted to look up atrial fibrillation. I hope I spelled that correctly as this is being recorded. I can quite easily find the standard concept ID just by a text search as well. So really, they're the two approaches that we typically go. We'll either take codes from another vocabulary and then map them into OMOP, or you can just build out these vocabularies based on string searches as well. So I talked about one relationship in OMOP, which is the relationship between the source vocabulary all the way to the standard concept ID. But another really important element of OMOP is that it utilizes clinical ontology hierarchies as well. So all the standard concept IDs within OMOP and the different tables are positioned within a hierarchy, which again you can utilize in your research. So if you take this example you see on the screen, this is the hierarchy for atrial fibrillation. So you can see the code for atrial fibrillation in the middle. And essentially, there will be a series of codes underneath this in the hierarchy, which are just more and more granular. So I'm only showing two here, but there's probably substantially more than this. So if you imagine I'm running a study and I was interested in lung cancer patients that had atrial fibrillation sometime in the past, I don't want to just capture patients with this 313217. Even if that's good enough for my database, I don't know if that's good enough for all my partner databases as well. So what I would do in my study, I would select this code and I would say, and choose everything below it on the hierarchy as well. And obviously you can refine this if there's an arm of the hierarchy that's not suitable. For instance, say like you weren't interested in another type of persistent atrial fibrillation, you can also exclude by the arm, but really this principle of hierarchies and selecting codes and hierarchies is really how we build up our clinical codes in the first pass, and then there are tools that we then refine them with as well. So this is I talked about that all of the OMOP concept IDs, standard concept IDs are in a hierarchy, And this varies between the tables that you're looking at. So in the condition occurrence table, the hierarchy that the standard concept IDs follows is SNOMED. It doesn't mean that you can't use classification concepts as well. So this goes back to what I said earlier, that there's these 3 types of OMOP concept IDs. So if you wanted to build a code list using a measure concept ID or an ATC concept, a measure class or an ATC class, just because OMOP uses SNOMED doesn't mean you still can't utilize these other classifications as well, because there's concepts that you can choose within OMOP that will then map back onto the SNOMED equivalents. So if I just summarize that again, essentially what I'm saying is OMOP follows a SNOMED hierarchy in the condition occurrence. It follows an RX norm hierarchy in the drug and other hierarchies in the different tables. But within the OMOP standardized vocabulary are these classification concepts, which you don't use in your tables, but they allow you to choose equivalent codes in OMOP if you're more familiar with measure or ATC and so forth and so on. And then just the final part of this slide, there's the source concepts here. So it doesn't matter what vocabulary you're starting with. Again, to emphasize this point, by the time it's in OMOP, it should be in the same equivalent code representing that clinical event. And this is just an acknowledgement that we've spoken about the concept relationship. So there's 3 types of concepts. The standard concept ID is what we use for our research. There's relationships between the standard concept ID and the non-standard. We can do a mapping for that. There's relationships between standard concept IDs in the hierarchy, which is really useful for building comprehensive, exhaustive code lists for our research. But there's other types of concept relationships as well. I'm not going to talk about these, but this just is to give you an idea that these exist. As you can see them on the left, the subsumes, RX norm ingredient, inverse, trade name, and so forth. And it just adds more breadth to what you can do with OMOP. So as you get into OMOP more, you might utilize some of these relationships to build out code lists. So we've spoken about the first 2 pillars of OMOP, the common data model and the standardized vocabulary. And it's these 2 factors that allow the standardization of our healthcare data across research networks and allow us to run these research network projects. Now I want to give a little acknowledgement to a little discussion, to the Odyssey community. So the Odyssey community is effectively the OMOP user community. It's international, it's multidisciplinary, and it's open source. And really, it's this collective of researchers across the globe who have built together this OMOP common data model, who maintain the standardized vocabularies, who build out these analytical tools that we can use against the OMOP common data model, and also run some pretty exciting projects and initiatives out there, which you can read about in the public. So this is open source. This is an open network. If your site has OMOP your data, you can join in with these Odyssey calls and get involved. Even if you haven't got OMOP data, you can still get involved as well. And I will just indicate some of the resources that we have for this. So Odyssey has its own website, which you can go and visit after this introduction course. There's a range of tools on here, so you can look up the symposiums that we have, also the Odyssey GitHubs that are coming up. But there's 2 elements I think will be really important for you as you begin your journey onto OMOP. The first is the Odyssey forums. This is a forum where you can, in different sub-forums, raise questions about elements of OMOP that you need more understanding on. So for instance, if you're building an OMOP CDM implementer, you can go here and you can ask a question, for instance, let's choose one here, concept recommendations for a table, so forth and so on. This is really your voice into the Odyssey community, to those experts who have been doing this for 14 years, building out this whole system. But if you really want to take another step into this, there's the Odyssey working groups. And I'd actually strongly encourage you guys to get involved in these as well. So the Odyssey working groups take certain elements of OMOP, so that can be the common data model, the analytical tools, maybe people that are interested in certain therapeutic areas such as oncology. There's an oncology working group. There's also geographical working groups and so forth. And essentially these working groups meet on regular basis to develop their area of OMOP, take part in projects, and just continually this progress of developing OMOP and the OMOP analytical tools. So there is an oncology working group in here. I'm not going to scroll down till I get to it, but I'd strongly encourage you guys to have a look and get involved in that as well. There we go. So off the back of OMOP and the hard work that Odyssey has done, we're seeing increasing adoption of OMOP, and particularly in the last 5 years, it seems that it's exponentially increased the adoption of OMOP. So this is just a very high-level overview of some of the adoptions of OMOP, particularly by some government agencies. So the FDA has used OMOP for some of their studies. We also see in Korea the adoption of OMOP. I think Singapore is currently adopting OMOP, and certain healthcare providers in China too. Europe, we already have the Eden project, which I believe some people on the call will be familiar with. And also the EMA has adopted OMOP for its Darwin project. So this is just to now give you an idea of OMOP in use, some of the actual use cases of OMOP, and show that effectively it does work. It's not just theoretical. So Darwin is an ongoing initiative by the EMA to use healthcare databases in the OMOP format across the EU to draw pharmacoepidemiology insights. It's in its third year now, where they are looking to run 60 studies, I believe. I think it's going up to 140 studies in the next year, the final year of the project. This has already led to several publications being put together, and I think is running, it says on the screen right now, up to 40 data partners. I think the first 2 years have been using between about 5 and 10 data partners for the studies, but this is an ongoing success of OMOP. And as part of that sort of continual development of OMOP and Odyssey, the Darwin developers have released a whole range of new analytical packages that answer different research questions that can be used against the OMOP data model as well. Another adoption of OMOP that I'd like to give a nod to is the Pioneer Consortium. I see some of my colleagues that I've worked with Pioneer on this course, I see Bertrand and Eamon. So over the last 4 or 5 years, the Pioneer Consortium has been using healthcare databases in the OMOP format to answer questions in the space of prostate cancer. And this has been a huge success, and it's bring a lot of us together as collaborators who otherwise wouldn't have met each other if it wasn't for this common interest in prostate cancer and also OMOP as the method to go about this. We've had a really successful last couple of years. We've run 3 study-a-thons that we've been involved in. We're now moving to our next stage, but again, OMOP is really at the core of being able to run these network studies, because without OMOP, trying to run these studies across 30 sites would be impossible. We'd be here for years trying to adopt each protocol and each analytical package for that. So another use case showing that OMOP can work specifically within the oncology space. And I'll leave you with this. There's a lot of publications now coming from groups that have used OMOP, Common Data Model, and also used OMOP research networks. I would say this was probably one of the groundbreaking studies of establishing OMOP as a working Common Data Model. It's the Legend Hypertension study. This was published in The Lancet about 5 years ago now. And essentially what they did, this is not an oncology space, but in the cardiovascular space, they took patients that were on 5 different classes of antihypertensive drugs, and they built an analytical package out, one analytical package out that compared these different classes of patients defined by OMOP definitions for the effectiveness of these drugs in preventing cardiovascular events such as acute myocardial infarction, stroke, and heart failure, and also 46 safety outcomes. So this was a huge success of a paper. I don't have the time to go through the details, but do look this up. I think we're sharing the link out afterwards. And one of the great things about OMOP and Odyssey tools, if I can get it up, is that in the spirit of openness and Legend itself, so you see this title up here, Legend is now a set of principles for for running these large-scale studies. And one of them is that you publish your results to get rid of publication bias. So what you will often see in the OMOP Odyssey community is that a lot of the packages will produce these dashboards which allow you to explore the data in its fullness, not just the statistically significant results. So this is for the Legend Hypertension study. You can see here that what they've done is they've compared for what have we got here? ACE inhibitors against beta blockers, but you can choose any drug family you want that was in the study. For an outcome of interest, so if I choose acute myocardial infarction, and then you can see these are all the databases that this study was ran over, the hazard ratios. We also have what's called the calibrated hazard ratios, which uses an analytical approach called empirical calibration to adjust for systematic bias. And you can deep dive on all of these outputs as well. So here we can see the actual Kaplan-Meier underpinning this particular comparison, which was ACE inhibitors, beta blockers in this data source. You can have a look at the systematic error. And I'm purposely not going into detail about any of these because I just want you to get a flavor of how much you can get from a standardized tool. This is one analytical package. That's a standardized analytical package in the Odyssey community for comparative effectiveness and safety. You can share this package out across your research network, and it produces as a standardized output this level of dashboard. So we are sharing this link out. You can look through it in your own time, but really, I'm just trying to get across to you how developed some of these packages are. They're not just very simple analysis. They can do quite interesting real-world evidence generation as well. Ooh. So I think that was my last slide. If I can go back to my deck. There we go.
I think that's
yes.
right. Thank you so much, James. That's been really good. We've got a couple of minutes if anyone's got any questions on that. I've certainly got some observations, but so let's start on the chat. So Gwankbao, I have a bit of a detailed question. We have self-designed RedCap CRFs. Could you advise on how we can feed this into USAGI after White Rabbit, Rabbit in a Hat? Is that one you can take now, James, or is that one that requires?
That is a question that I can introduce you to the right person question. So we can follow up with the right person at IQVIA who could help with that.
Brilliant. Eriseld, I saw you had your hand up as well.
Yeah, I was about to write it. So it was a very simple question. So for this text mapping, does it mean that the text must be structured before it gets mapped?
Good question. So there's two parts of the text mapping. There's at the ETL level, which I'm not at the ETL level, I'm on the analytics side, so I know less about. And then there's the analytics side as well. So if you're interested in primary lung cancer, right? So on the ETL side, there are tools that support that mapping of text records into OMOP concept IDs. I think that's getting covered more in the ETL training sessions that we're doing, but that exists. On the analytical side, there's two tools that we use to do text searches for identifying concept IDs. Obviously, if you're just searching by text, you do have to have a little bit of an idea of what the clinical terms mean. But a lot of them at the oncology level are pretty intuitive anyway.
If I could just add to that for Eriseld's benefit, I've seen the level of free text that is in your hospital. What's native tooling will not be good enough for you. You can kind of just about handle two situations. Very basic semi-structured information like ECOG equals 1 and those sorts of queries. Or it provides some rules for where to put the output from high quality NLP routines, but it doesn't have the NLP routines, broadly speaking. So Don't hold your breath and hope there's a miracle in open source. Otherwise, we wouldn't be offering NLP.
Okay. Conscious of time, I do want to just give Will a moment on next steps, but I guess just a reflection from me, sort of as I'm getting to know OMOP better, just how much has already been done and the benefits that accrue from that, whether it's on the kind of analytical packages that James shared at the end, whether it's on the mappings that allow us to bring in data from multiple different sources in different categorizations and different formats, but to bring it together into that OMOP standard. And then as a result of that, the opportunities that it gives us as a research community to scale across multiple sites and quickly. And some, I know some on the call who've been through the IDEAL4OMOP program, where we have our own bespoke common data models, which work well, but actually don't give the same opportunity for really kind of broad research participation in the same efficient way. So I'm really grateful to you, James, for sharing that with us and just opening my eyes, at least, to just how much thought, planning, preparation work is already out there, the foundations for us to conduct some really high quality research. Will, last couple of minutes, what can people look forward to next?
So, hi everyone, I'm Will Sopwith, working with James on running this program. Many of you will have heard from me already on email. And some of you may be sitting here on this first session thinking, "Ooh, maybe this isn't for me. Maybe I'm not going to get into this kind of level of technical detail." Others of you may be very familiar with that overview that James has given, and you want to dig deeper. And this is absolutely fine. What we're looking for, the thrust of this program, is to build collaborations, and not everyone in a team is doing exactly the same. So, in terms of skill sets needed, we need that broad range. So if you look at this presentation and think, oh, maybe this is just going to be too technical, I'd encourage you to hang on. Some of you may feel actually this is not for you, and that's absolutely fine. Please do let us know, and we won't plague you on emails. Just to say that we're developing a SharePoint site, which is shown on the screen here. And this will be the main portal for information. All the webinars, the recordings and the slides will be here for those that can't make the live webinars, and for also so you can look back on them and refresh memory of sessions that have gone before. We'll also be using this site to start building those collaborations around specific indications, to build the study teams, to give you a forum to share documents together as you begin to build protocols. So it's slightly a work in progress. This is an IQVIA SharePoint, so sometimes we have some slight issues with permissions and access. So over the next week or so, we'll be trying to get you all onto this SharePoint so that you can start to access it. And we'll put all the background information from today's session on this as well. And if you just click, but the main, as well as the SharePoint, if you just click through to the next slide, is the training email. There you go. Which many of you have already engaged with. Please do put this in your safe senders list so that things don't go to spam. As well as having the SharePoint, we will be communicating everything you need for the course through email as well. That'll be our primary communication point. So resources we'll be developing as we go along. And final slide, just to show you the links. And we will be providing these slides, so you'll have these links with you, exploring some of the things that James has presented today. So please do keep in touch. As James said at the beginning, please do get back with any particular areas that you want to dig into a bit more. And as I said, if you're feeling after this first session perhaps this isn't for me, please do let us know. Otherwise, I'll continue to plague you with emails from the training address. But yeah, we look forward to getting to know you all better. The next seminar you should have already received the calendar invite for is on the 2nd of May. If you've not received that, please do get in touch through that email, just to let me know that that you're receiving emails well. In fact, it would be good to do that anyway. If you could please respond to that invite for the 2nd of May, then I'll know that you're getting the emails from the training course, because we want to keep you in touch. So that's all from me. Thank you so much for joining today, and we look forward to continuing with you on this course. And thanks very much, James B, for such a comprehensive start.
Brilliant. Thank you all very much. Have a great day. Have a great week, and we'll be working with you again soon. Take care.
Thank you.
Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.